This is Algebra 2, Lesson 1-6, Linear Systems, Example 4. We'll continue with Example 4, writing system of equation as a matrix. Let's look at the conceptual understanding. We want to review the vocabularies that we're going to look at so that we can better understand as we go. So matrix is a rectangular array of values. You probably have heard of matrix before, but if you see these rectangular brackets and you have numbers 0 and 1 in there, those are called matrices. There could be other numbers like 2, 3, 4, -2. We usually deal with integers, but there could be decimals and practically any numbers. But these are called matrices, and they just look simple and easy to deal with, so we use them a lot for complicated problems. So let's look at part A. How can you represent 3y equals 1 minus 2x and 4x minus 10 plus 2y using a matrix? In the coefficient matrix, coefficient is any number in front of the variable. Coefficient matrix shows the coefficients of the variables in the system of equations. So just a matrix can mean a lot of different things, but coefficient matrix shows only the coefficients in front of these variables. So we're going to represent 3 and we're going to look at 3 and 2. So first we're going to change forms, make it into a standard form, because for matrices we are going to use standard form so that everything aligns together and it's easy to remember that the last line is for your constants. Okay, so that's called an augmented matrix. It shows all the coefficients and constants in the systems of equations. So we're going to write them in standard form. 2x plus 3y equals 1 is the first one, and 4x minus 2y equals 10 is the second form. And we're just going to look at the numbers. Forget about the variables. Just remember that the first column is for x coefficients, and then the second column is for the y coefficients, and the last one is the constants after the equal sign. So the dimensions of the matrix is R times C, where R is the number of rows, C is the number of columns. So here we have 1, 2, 3 rows, and 1, 2 rows, and then 1, 2, 3 columns. So this is a 2 by 3 matrix. So just count the numbers here, and this is how we read 2 by 3 matrix. There could be 3 by 3, there could be 4 by 4, but you just count the rows and columns to call them this way. Okay, so these are the vocabularies and we can write the system of 3y equals 1 minus 2x and 4x equals 10 plus 2y as 2, 3, 1, 4, -2, 10 in the matrix. So now we know how to write matrix, right? Part B, how can you represent the systems of equations of 3 variables and 3 equations with a matrix? What if we have 3 variables and we have 3 equations? We do the same thing. Make sure we line up the same variables in the first column, another column, and the next column. So then we are going to write the coefficients and the constants in the matrix. It shouldn't be that hard. So just align them and then you write the coefficient. So steps to write matrices. Write augmented matrix. Step 1, align the columns by the variables and the constant. And then step 2, pick out the coefficients and constant. And then step 3, write the numbers in order in the matrix. Okay, so let's see how these system of equations will look like in a matrix. You will see 1, 2, 0, 2, 1, negative 1, 3, 5, 2, 1, negative 4, and 10. Don't forget the negatives if you have a subtraction. Okay, so let's look at the last part. So it should look like this. The graphic is a little bit off, but you should have 1, 2, 0, 2, 1, negative 1, 3, 5, 2, 1, negative 4, and 10. So let's try number 4, A and B. Write the matrix for the system of equations, or the system of equations for the matrix. So part A, you're going to write the matrix. Part B, you're going to write the actual equations. See how you can convert one to another. So pause the video, come back when you're ready for answers. Okay, are you ready? So for A, you want to make sure that they are all aligned in columns. So they're already in a standard form, right? So you just have to convert that into matrix by looking at the coefficients. You have 3, and then negative 1 and 4. You have negative 2, 7, and 20, and that's it. You just need to rewrite that into a matrix form. And then part B, you want to write this into systems of equations. If you have 0, that means you don't have a variable. 0x here should just be 0. So you just have 2y plus 3z is equal to 4, right? And then the second one, you have x, 8x, minus 1y, which is just minus y, minus 2z is equal to 5. And then you have 2x plus 0y, which is just 0, minus z is equal to 9. So did you get all of them right? If you did, good job. If you didn't, you can keep practicing. All right, we can continue with example 4 in the next video.